So Unit 1, Alchemy, was made up of the first 5 chapters of study for the year. So I'm going to go through and overview the theme of alchemy that we saw, and then I'll go through each chapter one by one in review. So hundreds of years ago, alchemists were trying to turn ordinary substances into gold. The overarching question for this unit, is it possible to create gold from other substances, was accompanied by 2 other important questions. If so, how is it done? And if not, why not? In this unit of investigation, you were introduced to what matter is and how density can be used to determine if matter had changed into a different substance. You were also introduced to the periodic table of elements. Next, you considered the merits of historic models of the atom before arriving at a basic model of the atom. You studied nuclear reactions, moving electrons, naming compounds, and the 4 different types of bonding that exists for different substances. Throughout the unit, you returned to the central question, is it possible to create gold from another substance? The ultimate answer to that question is both yes and no. The gold found here on Earth was created somewhere in the stars through nuclear processes. However, that option is not available to us in the laboratory. So, while it is theoretically possible through nuclear chemistry, making gold from other elements is not feasible on Earth. Chapter 1 was called Defining Matter, and we started the chapter with the gold penny demo. We came up to the front of the room, we put a penny in a beaker of some sodium hydroxide and zinc metal, and we saw that the copper-colored penny turned a silver color. And then we took the penny out of the beaker, heated it up on the surface of the hot plate, and we saw that it turned into this golden color. And that demo really generated a bunch of questions that fueled not only this chapter, but the rest of the alchemy unit. We started in terms of content by looking at laboratory equipment and lab safety. You should be familiar with the safety rules we've been hopefully following all year, and all of the laboratory equipment, most of which is summarized here, but you can always reference your note packet. You should be familiar with how to identify it and what the tools are used for. We defined chemistry as the study of matter, the changes it undergoes, and the energy involved in those changes. And if we think about the way the year was structured, the year was really structured by taking apart that definition into its thirds. And the first third of the year was studying matter. The second third was studying the changes that matter undergoes, both physical and chemical. And then the latter part of the year was looking at the energy involved in those changes. In order to study chemistry appropriately, we use observations, inferences, and hypotheses. So observations are anything we can say about matter using our 5 senses. So we witness something, we make observations. This substance has a certain texture, there's an odor coming from this reaction, whatever it may be. Then the next step would be to make an inference. An inference is a mental judgment that's really based on some prior knowledge or some past experience. And then a hypothesis is a restructuring of an inference in the if-then format, which then allows us to set up controlled experiments and ultimately come to some sort of a final answer for why we are observing what we observe, or at least a good enough justification to generate enough evidence to support a justification for the observations we are making. We then went on to define matter as anything that has mass and takes up space or has volume. And we saw that we can classify matter in one of 2 ways. We can classify matter based on its composition, what it's made of. For example, water is made of hydrogen and oxygen in a ratio of 2:1. Or we can classify and talk about matter based on its properties. So water is a clear, colorless liquid. The banana is a yellow-green solid, for example. Not everything is matter in the universe. Some examples of things that are not matter would be a rainbow or any form of light, which we classified as energy. But some other things that are not matter that wouldn't be classified as energy could be things like feelings, memory, love, or in this case, a reflection would be things that are not matter because they do not take up mass and don't have volume, and they are not tangible. You remember we sort of use that as a quick judgment for whether or not something is matter. We broke apart this definition of matter into the 2 components that are important in that definition, mass and volume, and we defined mass as the amount of matter in a substance, and the units that we used commonly throughout the year were grams and kilograms, and volume is the amount of space that the matter occupies, and the common units we used were centimeters cubed, milliliters, and liter. We looked at measuring mass using a balance and measuring volume in one of 2 ways. If it's a regular object, using a ruler, and if it's a cube or a rectangular prism, doing length times width times height. If it's a cylinder, there's still a geometric formula that we can use after taking some measurements with a ruler to find the volume. But there are some objects that are considered irregular, which means that they don't have sides and they don't have a geometric volume formula that will allow us to easily calculate volume. So we have to use a method known as water displacement. And if we remember, water displacement is we fill up a container with water, we take note of how much volume the water is, and then we put the object into the water. The object literally displaces some of that water so it can take up space, and the water level increases, and the difference in the water level corresponds to the volume of the object that was placed in there. So if we find the mass using a balance, we find the volume using a ruler or using water displacement, then we can find density, which is mass over volume. Really what density is referring to is how much matter is in a given amount of space for an object. And that is a characteristic property for matter at a given temperature, meaning that every sample of matter has a specific density, has a specific amount of mass in a given amount of space that we can use to help identify the matter. The last thing that we looked at and you should be familiar with is the relationship between density, mass, and volume, in the way that you could take these two examples here. If I have two samples of matter where the masses are equal, indicated by the same number of particles in each box, but the volumes are different, then the larger volume object is going to have the lower density because that mass is dispersed over a larger space, where the smaller volume object is going to have the higher density because its mass is more compact, it's closer together, which is after all what density is measuring. And in the example on the right, these two substances have equal volumes indicated by the boxes that the matter is in, so the squares are theoretically equivalent in volume. The object that has the higher mass, meaning there's, in this case, there's more particles in that substance, is going to have the higher density because even though the volumes are equal, there's more matter packed into the given amount of space there than there is here. So we should be familiar with those relationships, mass, volume, and density. That brings us to the end of Chapter 1 in terms of our quick review of the important topics. You should use your Chapter 1 note packet, though. Make sure that you're looking at the lesson objectives, making sure you feel comfortable with those. And then, of course, working through any practice problems you have left in your note packet, in the textbook in Chapter 1, and in the practice problem packet that I handed out for the final exam review.